Hello everyone, welcome to another class of Java programming, and in this class we will comprehensively discuss about the bitwise operators. What are bitwise operators? Bitwise operators will act upon the individual bits of an operand. As we know, any number can be represented in its binary form, and the binary bits are either 0 or 1. So if you take an example here, the value or the byte value for 42 in binary is 00101010. So to know if this binary represent equivalent to the integer value 42, you can start computing by multiplying each bit with the power of 2, starting from right with 2 power 0. The first bit is multiplied with 2 power 0 and proceeding towards the left with the rising exponent value like 2 power 1, 2 power 2, 2 power 3 and so on and so forth. So this is how a positive number can be represented. Coming to the representation of the negative numbers, Java uses a method called as 2's complement, where the ones are inverted to 0 and zeros are inverted to 1, all the bits in the value, and then adding the 1 to its result. For example, to get a negative value of 42, that is minus 42, the actual representation of 42 is 00101010, the binary representation of number 42. Now we are trying to represent the negative 42, that is minus 42. The first step is to invert the bits. So here is the inversion process. So if you see, the number 0 is converted to 1 and 1 is converted to 0. The first step is done. And the next step is we are adding 1 to the result. So this number represents a negative 42. Now how do you decode the value to get minus 42? That is simple. We will do a reverse process, that is change again the zeros to ones and ones to zeros and add a 1. So it will give the actual number. So this is about the bitwise operator and the binary representation of a positive number and negative number. And moving on, the bitwise logical operators. The bitwise logical operators are bitwise AND, OR, XOR and NOT. So how are these operations performed between the two operands? Any operand will either have the binary representation, that is it can have the bit 0 or 1. So if the bit of the operand A has 0 and bit of the operand B has also 0, then A or B is 0, A and B is 0, A XOR B 0 and complement of A will be 1. Okay, so this diagram will give you the complete representation of the logical operations between the two operands A and B. So this is about the bitwise logical operators. And there are bitwise logical operations like a right shift operator, unsigned right shift operator, left shift operator, unsigned left shift operators. So what left shift operator? So the general form of any left shift operator is like this. The value less than represents a left shift operator and the number, where the num represents the number of positions to which the left shift has to be performed on the given value. For example, A is a value, A is a number, this is called as value, and if I say left shift 2 times, okay, now the binary representation of 2 is 0010, isn't it? This is the binary representation of 2. Now I am asking to shift the positions twice. So in the first step, it is shifted towards left 2 times. So it becomes 0, 0, 1 and 0. And again in the next step, it becomes 0, 0, 0 and this becomes 1. So the binary representation of this binary value is 8. So the result of this integer value or variable result will hold the value 8 after the two positions left shifting the number. So this about the left shift operator. And the right shift operator also works similar to the left shift, but instead of moving uh, moving towards the left side, the positions are moved towards the right shift or right side. So the general form of the right shift operator is value greater than is the symbol to represent the right shift operator. And similarly, the number represents the num represents the number of positions to the right shift, the value in value. So for example, if I take the value of 8, int a is equal to 8, I am asking, so I want to shift the number of positions towards right side for 2 times. So if you take 8 and the binary representation is 1, 0, 0, 0 is a binary representation of 8, and I want to shift it twice towards the right side. So in the first step, the first shifting will be 0, 1, 0, 0. And the next step, it shifts again to 0, 0, 1, 0. So we are moving the positions towards the right. Okay, so the binary representation, the equivalent number to this binary representation is 2. So the result will hold the value 2 after 2 positions right shifting the number 8. Okay, and the next one is unsigned right shift operator. Java's unsigned shift right operator is represented with 3 greater than symbols, always shifts zeros into the higher order bits. Shifts to the higher order bit. For example, if a is equal to -1, it is represented as -1 representation of an integer looks like this. Okay, now we are shifting 24 times towards the right. The result will be this one. The result will be this one, which is equivalent to 255, an integer value. So this is about the unsigned right shift operator. So unlike the unsigned right shift operator, there is no left shift operator because the logical and arithmetic left shift operations are identical. So this is about the bitwise operator. See the code illustration of how all these bitwise operators work, and we will also understand few more Java examples on these bitwise operators. So it will give you a conspicuous ideas of how these bitwise operators actually work. So see you in the next class. Thank you.